In this video, we're going to look at how to use the convolution theorem to work out inverse Laplace transforms of functions. So the statement of the theorem says the inverse Laplace transform of f of s is f of t, and the inverse Laplace transform of g of s is g of t. Then the inverse Laplace transform of the product of f times g is given by this integral here. So we are now going to use the theorem to find the inverse Laplace transforms of some of these rational functions here. We're going to start with A. Of course, this convolution theorem is going to be used in conjunction with some standard table of Laplace transforms, which we also have here. So we shall refer to it at intervals. So in this case, we've got 1 over s squared s plus 2 all squared. So what we're going to do is we're going to let f of s be 1 over s squared, and then we're going to let g of s be 1 over s plus 2 all squared. Then from the table of Laplace transforms, which we shall refer to just now, then f of t is going to be equal to so Laplace transform of f of t is 1 over s squared. So f of t is going to be, so here from this line, so if this is 1 over s squared, it means that our n is equal to 1. So this side, we're just going to have t. So going back to this side, then f of t is just equal to t. And then for this second one, we've got 1 over s plus 2 all squared. So from our table, that is going to be this term here. Again, if this is 2, it means n is equal to 1. So this side, we're going to have t e to the, our a is going to be minus 2. Okay, so going back here, then g is going to be equal to te to the minus 2t. And so the inverse Laplace transform, so if you like, so the inverse Laplace transform of this going to be p of t. So this is going to be the convolution of f with g. It's going to be equal to the integral from 0 to t. So this one we are going to take as t minus alpha, and then te to the minus 2. Sorry, this is going to be alpha. So alpha e to the minus 2 alpha d alpha. Okay. So this is the same as the integral of t alpha minus alpha squared e to the minus 2 alpha d alpha. And then using tabular integration, we can evaluate this. So if we have got t alpha minus alpha squared here, its derivative is going to be t. Remember, our variable is alpha, so this is going to be t minus 2 alpha. Then derivative of that is going to be minus 2. Derivative of that is going to be 0. And then in the other column, we're going to have this one and its derivatives. So that's going to be minus 1 over 2. It's going to be 1 over 4. It's going to be minus 1 over 8. And then we're going to match these accordingly. So the first two will be plus, the next two will be minus, and the last two will be plus. So, and then we're going to notice that so this is negative, this is negative, this is the only one that's positive. So what we can do is this. So P of t is going to be the negative of, then we're going to have alpha into t minus alpha over 2 plus t minus 2 alpha over 4, then minus 1 over 4, all this times e to the minus 2 alpha, then from 0 to t. So that's what we're going to have. Now, if you plug in alpha is equal to t, plugging alpha is equals to t, this term is going to be 0, because you're going to have t minus t there, but this one is going to be negative t over 4, but we already have a negative here, so that's going to be t over 4. Then of course that one is also 1 over 4, then e to the minus 2t. Then when we plug in alpha is equal to 0, again this term is going to be 0. This one is going to be t over 4. So there's a minus here, but there's a minus which goes with the fact that that is the lower limit. So that's going to be t over 4. And this one is plus, and then the minus which goes with the fact that that is the lower limit. It's going to give us that as a negative. So that is going to be the inverse Laplace transform of this function here. So that's the first one. Of course, if we like, we can regroup these terms. If we do that, then if we factor out 1 over 4, then we can write this as t plus 1 e to the minus 2t plus t minus 1. Okay, so that is that. In example B, we have s over s minus 1 into s squared plus 4. Now, what we're going to do here, the way we're going to split this, so let me just show you the, maybe before we go there, so we have got s over s minus 1. 1 over s minus 1, we can find the inverse Laplace transform of it from the table of Laplace transforms. So what we're going to do is we're going to let f be 1 over s minus 1. What we don't have is a term like this in the table of Laplace transforms. Just go to the table yeah, so we have got this type of term, and notice it doesn't have a term of s in the numerator. The term that does a term of fs in the numerator is that one, which in our case is going to correspond with the s squared plus 4 term. So that is going to be our f, and then f of t is going to be e to the power t from the table of Laplace transforms. Then our g is going to be s over s squared plus 4, and I just referred to this one here. So in our case, our a squared is 4, so our a is going to be equal to 2. So this is giving us g of t is cosine 2t. So our inverse Laplace transform going to be the integral from 0 to t. Now notice we can choose to go with the t minus alpha either here or here, and it looks like it's going to make life easier if we put it here than here. Notice that since the convolution is commutative, we can go with t minus alpha here or there, but one may be more involving in terms of the integration than the other. So then this is going to be 2 alpha t alpha. Then we just again integrate this. We can I'm going to use tabular integration again. We could factor out the e to the power t, but well, it doesn't make anything any more complicated, so we're just going to work with it. So if we take the cos 2 alpha and differentiate it, then we're going to have negative 2 sine 2 alpha there, then negative 4 cosine 2 alpha, then e to the t minus alpha. Remember alpha, so we're going to be integrating this with respect to alpha, so that is what we are going to get in this case. So that is going to be plus, that is going to be minus, and then the last term, which is going to be an integral term, is going to be the integral of the product of these two exactly as they stand there. So what we're going to do is if we just put the integration limits aside for a moment, so integral of e to the t minus alpha cosine 2 alpha is going to be, so if you look at these two terms here, they're going to be both negative because there's negative here, and just one moment, they are not both going to be negative. So this one is negative and this one is positive. So we are going to have e to the t minus alpha. Then we're going to have 2 sine 2 alpha minus cos 2 alpha. So that's just from these two terms here. And then the last term is going to be minus 4 times the integral of t to the minus e to the t minus alpha cosine 2 alpha d alpha. And then of course this is exactly the same as that. So that's when we're going to take this to the left hand side, and in fact, if we call this I and I, then on the left hand side we're going to have 5 of them. So 5i is going to be e to the t minus alpha brackets 2 sine 2 alpha minus cos 2 alpha. So I is going to be e to the t minus alpha over 5 2 sine 2 alpha minus cos 2 alpha. Then we're going to take this and plug it into our convolution here. Okay, so P of t is going to be, so we're going to evaluate this from 0 to t. So sine 2 alpha here minus cosine 2 alpha 0 to t. So what's going to happen is when alpha is equal to t, this is going to be e to the power 0. So it's just going to be 1 over 5 2 sine 2t minus cosine 2t. So that's the first term. Then take away when alpha is equal to 0, the exponential is just going to be e to the power t. Alpha is 0. The sine term is going to be 0, cos is going to be sine 0. The cosine term is going to give us negative 1. So that's going to be negative 1 there. So at the end of the day, so our Laplace transform is going to be e to the t over 5 plus 1 over 5 2 sine t 2 sine 2t minus cosine 2t. So that's going to be our inverse Laplace transform. Right. At this point, we are going to give you the opportunity to have a go at these two here. You want to have a go at C and D. You can pause the video, and then when you continue the video, then you can compare with our solutions. All right, we're now going to scroll down to our answers for C and D. We hope these are useful to you, the videos. Please do not forget, of course, to subscribe to our channel to support us so that we can make more. If you've got any questions, you can post them in the comment section. All right, so for C, if f is 1 over s minus 1 squared, then the inverse is going to be t e to the t. G is 1 over s plus 2. That is going to be the inverse. And so the convolution, so this time we're putting the t minus alpha on the g, and then the negative 2t we can actually factor out, and the 2 alpha and the alpha here will add up to 3. So we integrate this using tabular integration, and it gives us that. And then when you plug in t and 0, this is what we have. And then multiplying through everything by e to the minus 2t, that is going to be our inverse Laplace transform. Then for D, if f is 1 over s squared plus 9, then f of t is going to be a third sine 3t. This is because you look at the table here, the term that does not have as in the numerator has got a, so in our case a is 3, so that's why we end up with that 1 over 3 there. And then the other one is just giving us the cosine. Then the convolution looks like this. Then from here to here we apply the trigonometric formulas for sine A cos B. So sine A cos B is 1 over 2 into sine A plus B plus sine A minus B. So for the A plus B, the minus 3 alpha and 3 alpha is going to cancel out, and then this is the other case. So this one doesn't depend on alpha now, so it just integrates to that. This one we're going to have to divide by -6. So this was supposed to be negative, but because this is negative, it becomes positive. We'll plug in the limits, and so the final answer is going to look like this because these two terms cancel out. All right, thank you.